everyone. Welcome to today's live broadcast, the Pesticide Explorer Collection, multi-residue pesticide analysis made easy for the routine laboratory. I am Brenda Kelly Kim of LabRoots, and I'll be your moderator for today's event. We are delighted to bring you this educational web seminar presented by LabRoots and sponsored by Thermo Fisher Scientific. Thermo Fisher Scientific is a world leader in serving science, whose mission is to enable customers to make the world healthier, cleaner, and safer. Thermo Fisher Scientific helps their customers accelerate life sciences research, solve complex analytical challenges, improve patient diagnostics, and increase laboratory productivity. For more information, please visit www.thermoscientific.com. We have a few announcements before we begin. This webcast is designed to be interactive, and we encourage you to ask questions during the event. You can submit your questions by typing them in the Q&A box, which can be found by clicking on the green Q&A button at the lower left of the presentation window. We'll try to answer as many questions as we can. You can enlarge the slide window by clicking on the screen icon in the lower right-hand corner of the slide window. If you have any technical problems viewing or hearing this presentation properly, please click on the support button at the top right of your presentation window, or submit your problem through the green Q&A button lower left. I would now like to introduce today's speakers. Katerina Bousova studied food chemistry and chemical analysis at Faculty of Food and Biochemical Technology at the Institute of Chemical Technology in Prague, and finished her master's degree in 2006. From 2006 to 2010, she worked as a chemical analyst at the Department of Chemistry at the State Veterinary Institute in Prague. In 2010, Thermo Fisher Scientific established a new laboratory food safety response center in Dreieck, Germany, where Katerina started working as an application specialist. She was a member of a small team which focused on the rapid development of analytical methods to respond to emerging contaminations in food. In 2013, the name of the group has changed to Special Solutions Center, and the field activity has broadened. Katerina is still responsible for development of new analytical methods, but is also giving the presentation about new trends in food safety areas, giving trainings for customers, and preparing various workshops in the area of food testing. Ed George has a BS in chemistry from the University of Notre Dame with a concentration in environmental science. He worked for 15 years in the commercial environmental laboratory industry. He participated in several collaborative method development projects with the U.S. EPA. From 2005 to 2009, he worked for Varian Incorporated as an application lab manager, developing applications for pesticide residues in food and water for major product launches in ion trap and triple quadrupole MS systems. Ed joined Bruker Daltronics in January 2010 as an application chemist, and later became product manager for the Scion single quadrupole instrument, responsible for product marketing, definition, and implementation, acquiring voice of customer feedback for product feature input, competitive analysis, sales training, global seminars for dealers, inside sales, and margin analysis. Ed is currently a senior application scientist at Thermo Fisher Scientific, supporting the Life Science Mass Spectrometry Group for environmental and food safety analysis. I will now turn it over to Katerina for the first part of the presentation.
Good morning, good afternoon. Thank you for a nice introduction. And at the same time, very welcome everyone to this webinar giving details about Pesticides Explorer collection. It's a package focused on a routine multi-residue method for determination of LC amenable pesticide compounds using traditional QuECHERS sample preparation, followed by different instrumental techniques. First, I will give a short introduction to pesticides area. Pesticides are extensively used in agriculture to protect crops from pests and improve yields. There are in use more than 1,000 different active substances with different chemical properties and various fields of application. There are various ways how they control the pests. Some of them are biodegradable, however, some of them are persistent and can stay in the environment for very long periods. Typically, they are thoroughly tested and evaluated before approval, and they are all over the world legislatively regulated. But the problem occurs when the pesticides are not applied in accordance with the intended purposes and when the guidelines for the correct application are not followed. In some countries, the most dangerous banned pesticides are still used. So then no wonder, and because of a high media publicity, that there is a significant public concern about pesticides use. The Pesticides Explorer collection is a comprehensive solution for the analysis of pesticides in food matrices. It's a complete workflow including sample preparation, LC-MS methodology, and data processing. It complies with regulatory methodology recommended by the FDA, USDA, SANCO, and the Chinese GB standard testing. It offers a robust and reliable solution using both the triple quadrupole platform and QE-focus to demo chemists, sales, and customers. And it's truly a start-to-finish workflow. In this slide, you will find a short resume of the 4 different bundles available. Standard Quan for routine quantitation with the TSQ Endura. Second, Premium Quan for routine ultra-sensitive quantitation with the TSQ Quantiva. Third, High-resolution accurate mass Quan for high-resolution quantitation using the QE-focus. Fourth, High-resolution accurate mass screen and Quan using the QE-focus. All bundles include the Ultimate 3000 with 3400 RS pump, a QueCHERS extraction kit, and the HPLC columns needed to run the recommended methods, which are also included. A software kit including TraceFinder is part of the Quan workflows. Also in the screening workflow, other software packages are included: Sieve, Compound Discoverer, and Mass Frontier. The high-resolution accurate mass library is also included in all bundles. A user guide which assists the customer on the installation of the software. At this time, we are not able to provide standards as part of the bundle collection. However, we will be happy to assist the customer on locating and ordering the different chemicals. There are many challenges which we have to face during pesticide residue analysis. Apart from the large amount of pesticides and variety of different matrices, challenges such as breakdown or interaction of the pesticides, matrix binding, and quality assurance can be challenging. It's required to analyze very low levels of pesticides. General maximum residue limit is 10 ppb. And the testing labs have to be able to analyze the samples and provide the results as fast as possible because the tested food often can't be stored very long time. Let's have a look at some sample preparation issues. Despite the stability of most contaminants, for some analytes a poor recovery can be observed as the temperature can play an important part during the sample processing. These compounds in red show sensitivity when not cooled during sample preparation. It is recommended either to reduce the temperature with solid carbon dioxide and perform the homogenization of a frozen sample. In the picture is shown the cryogenic comminution, the process whereby the sample is made a solid with carbon dioxide and homogenized. In this slide is shown the difference of ambient and cryogenic processing and what effect it has on the recovery for some typical temperature-sensitive compounds. The increase of recovery by using cryogenic comminution is dramatic, around 50%. The blue columns. Before the QueCHERS method was introduced, sample preparation was carried out typically by liquid-liquid extraction followed by cleanup on galvanization chromatography or solid phase extraction, after which it was injected on the detection system GCLC or GCMS or LCMS. Nowadays, these techniques are for pesticides analysis mostly replaced by QueCHERS. Let's talk in more details about this technique. There are many advantages of using QueCHERS approach. The biggest benefit is its simplicity. Almost any lab can do the analysis. It covers broad range of compounds ranging from very polar compounds like some organophosphates, acephate, metamidophos, for example, to non-polar compounds like organochlorines. The simple workflow lowers the method costs and improves the lab throughput. QueCHERS can be used either with LC or GC determination step. However, the cleanup step is rather limited. Only dispersive SPE can be employed. It is not suitable for less polar pesticides in fatty foods, and mainly with GC determination, some problems may occur during acetonitrile injection. For example, long-term stability, vapor overflow, and inland contamination. Also, the lifetime of the GC column is significantly reduced. Due to its huge popularity and many benefits, the QueCHERS approach was employed in our method for Explorer collection. The matrices tested for the Explorer collection were strawberry, representing a high water and sugar content matrix, Leek, as a complex and green vegetable with high pigment content, and floor, representing dry matrix with very low water content. The European version of the QueCHERS extraction makes use of 10 grams of sample, 10 ml of acetonitrile, sodium chloride, magnesium sulfate, and citrate salts, and is recommended without any cleanup. The final extract is then analyzed by LC-MS without making use of dispersive SPE. The AOAC version of this extraction makes use of sodium acetate and is also available to our customers. Please keep in mind that different matrices may need a different extraction approach and/or a cleanup step. I will show you some examples later. Pesticides Explorer includes the part numbers of all consumables and chemicals which are needed for pesticides analysis. You can use either QueCHERS kits with pre-prepared extraction tubes containing the needed salts, or you can go for more cost-effective option and order the QueCHERS pouches. Here you can see improving QueCHERS extraction tips and tricks for some challenging matrices. For dry food with very low content of water, it is recommended to add water to enable adequate partitioning and reducing interaction of pesticides with matrix. The production of heat is also reduced and temperature-sensitive compounds are protected. For food containing fat or VOX like avocado, it is recommended after extraction to include a freezing out step and employ the cleanup tube with content of C18. Additional cleanup might be necessary for very complex matrices as tea and spices. For example, very effective is graphitized carbon black, which is used for removing the pigments. For matrices with high content acids, can be helpful to adjust pH to neutral values to increase recovery and reduce co-extraction of matrix interferences. The Pesticides Explorer contains also the information about available QueCHERS cleanup tubes. You can learn more about sample preparation from the enclosed video prepared by our experts in this field. Pesticides Explorer collection will contain also listed useful links and other open sources with information related to this topic.
Okay, thank you very much, Katerina. This is Ed George. I'm going to go ahead and proceed with the presentation here, talking a little bit more about the methodology employed in the Pesticide Explorer collection. And as you can see in this slide here, we show our triple quadrupole instruments on the left, doing routine quantitation and identification of compounds. That's most common in laboratories today for these types of pesticide analyses. And basically we have two instruments shown there. We have a TSQ Endura and a TSQ Quantiva. And we can do identification, quantification, and of course reporting in that package, as done normally in laboratories for food safety. But we also offer a high-resolution accurate mass solution as well. And with high-resolution accurate mass, you can do screening and identification of compounds that are not necessarily part of a target compound list. So in traditional laboratories, oftentimes you have a large list of compounds with transitions. You input them into a big long method and you run a target analysis list with SRM. And basically in the high resolution accurate mass, you can have a target list, but you can also look beyond that target list into a screening type of mode for compounds that you may not be expecting to be in your samples. So it offers laboratories some increased flexibility in going forward and looking for other compounds that may be in the sample. So the methods in the Pesticide Explorer collection for the triple quadrupole instruments are included here in this slide, and you'll see here that there is a 15-minute and a 25-minute runtime LC method. The 15-minute method is more of a high-throughput method, and the 25-minute method is more of a comprehensive larger list pesticide method. And the methods are available on both platforms. The scanning mode that is used for these particular triple quadrupole methods are timed SRM methods with polarity switching occurring throughout the entire run. And as you can see, the two methods contain either a smaller 276 pesticide methods that's run in 15 minutes or a larger method run in 25 minutes containing about 440 compounds in that particular method. And the really nice thing about this collection is that the software that's included, the TraceFinder, contains a master method as well as an acquisition method. So the complete method is there and ready to load on your instrument, and so simply you set up the conditions of the mobile phase and inject the pesticide standards, and you will be off and running on this method. All the methods use an AccuCore AQ C18 column, 100 by 2.1 with a 2.6 micron particle, which is a really good standard column for these particular pesticides and gives excellent peak shape for a wide variety of polarities that are in the methods. The methods for the high-resolution accurate mass include two methods. There's a 15-minute high-throughput method also, and then the 25-minute longer method on the QuEFocus platform. And the scan modes that are available are full scan with data-dependent MSMS with polarity switching, and also another mode known as variable data-independent acquisition, which is available in most parts of the world except the U.S., in which you can do a more overall or arching overall screening type view of full scan with MSMS occurring all the time in the analysis. And in both cases, you get a high-resolution accurate mass library and compound database, which can be used, again, to look for target compounds, as well as compounds that are beyond your target compound list. And the software that's included, again, is TraceFinder software with the master method. And what's really nice is that all methods are using the same mobile phase and the analytical column. So if you are using the triple quad solution, you can transfer the method to the high resolution accurate mass instrument in the same laboratory, get the same retention times, and be on your way to learning high resolution accurate mass if you're new to this particular type of analysis. The extended or 25-minute method, as I mentioned earlier, contains 440 pesticides on a 25-minute run. And as you can see, pictured to the right is a illustration of the China GB standard. And most of the compounds that are listed in this particular analysis cover the European standards as well. It's a 5 microliter injection, and the complete compound database in TraceFinder is available. It comes with the Explorer collection package, with the instrument method and the TraceFinder master method for processing the data, which again allows the user to set this method up very rapidly in the laboratory. And this high throughput 25-minute method uses a gradient that's listed here. It's basically a water methanol type gradient, and we use a 1 microliter injection in this particular analysis for the high throughput method. And this allows less matrix to be injected onto the system, and we show here a flow rate of 300 microliters per minute with a general runtime of 15 minutes. And so this gives you a relatively high throughput method, getting 4 samples completed in an hour, and again, looking for 276 pesticides in the analysis. So here's a little bit of a close-up view of the chromatogram in the high throughput method. And you can see here we have great peak shape for all the compounds in the method, as well as plenty of scan points across the peak. So the peak widths are narrow, and the instrument is easily fast enough to give you plenty of peaks for quantitation. This is based on a 1 microliter injection, and the SRM list, the collision energies, the retention times, all of that is figured out for you. It's in the TraceFinder software, and it's ready to go. So this makes it very easy for labs to set up the methodology and really get going, because that's really what a lab needs to do, not spend a lot of time trying to set up these methods and think about what the SRM transitions are. And so this just shows an overall picture of the TSQ Endura API conditions. And as you can see here, we're using electrospray, heated electrospray, generally spray voltage of 3700 volts. So these particular settings were optimized for this particular analysis. And so what we wanted to do was make sure that we were able to meet the regulations and to provide a method that is truly worthy of being a compliant method. And in the next few slides, what you'll see here is a validation of the Endura method, so that way it shows the good reproducibility and the types of data that you can expect when you look at the Pesticide Explorer collection package. And with that, I'll hand it back over to Katerina.
Thank you, Ed. Here's Katerina back, and I will continue in presentation and give you more details about the validation of our method. European Union guidelines for single laboratory validation and pesticides residue analysis were used to establish method performance criteria, including linearity, matrix effect, LOD, LOQ, precision, and accuracy. All method performance parameters were compared to the relevant legislative requirements and MRLs. For quantitative analysis, matrix match calibration was employed, and according to the legislation description, for compounds having more isomers, only 1 values were established. The precision and true-ness was determined by the measurement of 6 replicates of 45 samples at level of 10 and 100 ppb. Above this, the accuracy was determined for some compounds by measurement of certified reference materials. In the next slides, details about validation results will be given. However, please be informed that duration of this webinar is limited, and consequently the complete results cannot be shown in all details. LOQ values are always one of the most tricky issues, since the determination is not always unambiguously described. We have established LOQ values according to the UPAC signal-to-noise approach, since this determination is often applied as standard determination method in the literature and well accepted among the users. The acceptance criteria was set for these calculations as LOQ less or equal to MRLs. In the figure, you can see the pie chart showing the percentage distribution of LOQs for strawberry matrix. 90% of values are under 1 ppb, 8% of LOQs are from 1 to 10 ppb, and 2% of compounds are above 10 ppb. All LOQ values fulfilled our criteria and are smaller or equal to MRLs for strawberry matrix. Similar figure, but showing the results for Leek matrix. You can see here the LOQ values are at average higher because of the more complex matrix and more interactions between the target compounds and matrix parts. LOQ values under 1 ppb are valid for 76% of all target compounds. 22% of LOQs are in the range from 1 to 10 ppb, and 2% of compounds are above 10 ppb. But again, all LOQ values fulfilled our criteria and are smaller or equal to MRLs for Leek matrix. And last matrix, floor, wheat floor. Here, the results are very similar like for Leek matrix because floor belongs to more complex matrices too. LOQ values under 1 ppb were reached for 75% of all target compounds. 22% of LOQs are in the range from 1 to 10 ppb, and 3% of compounds are above 10 ppb. Again, all LOQ values fulfilled our criteria. In this slide, you can see the comparison of LOQ values for 11 representative compounds for all 3 matrices and solvent. All values are safely under the level of 10 ppb, which is a general maximum residue limit for compounds and commodities where no extra value is specified. Method recovery and repeatability were determined at 2 levels, low and high, 10 and 100 ppb. For some compounds, the values were multiplied by 2, like for example for diniconazole, because of the restricted availability of standard mixtures. For each level were prepared and analyzed 6 replicates. The low level of 10 ppb was chosen as a general value for MRL. In the table are shown the results for recovery and repeatability for 12 representative compounds. The acceptance range for recovery was set from 70 to 125%, and all these chosen compounds fulfill this requirement. The recovery results for lower level at 10 ppb are expressed in the graph under the table. Repeatability, or more precisely the method within day precision, was established from recovery samples again at 2 levels, 10 and 100 ppb, and in 6 replicates. In the figure are shown the results for lower level of 10 ppb for 12 representative compounds. All values fall in the range from 0 to 20%, that was our criteria. Within day precision is demonstrated in this slide on the peak of Pyraclostrobin. In the right low corner, you can see the chromatograms overlay of repeated measurements at low level with reached value of RSD 9%. The injection precision was determined by the measurement of 10 repeated injections of standard mixture in solvent at level of 100 ppb. The chromatograms overlay is shown for Pyraclostrobin on the left. Finally, the method bias was tested with external quality control materials. For this purpose, 4 different FAPAS samples as leftover of earlier proficiency test samples were purchased and analyzed for the target compounds. Due to the limited availability of QC materials, the purchased FAPAS materials were slightly different in matrix constitution from our target matrices. Lettuce instead of leek and melon puree instead of strawberry. The wheat flour certified reference material was available. However, only a limited number, around 4% of target pesticides, were presented in these samples. Despite of a different matrix constitution, the measured results showed very good agreement with the assigned values or were lying within the acceptance range, as results in the table demonstrate. The peaks with an excellent peak shape of analyzed pesticides in the quality control material of wheat flour and melon puree are shown in this slide. In next slide are shown all product ions, for example, of compounds determined in quality control sample of lettuce puree. 1 quantifier peak and 2 confirming ions qualifiers. For the metamorph are shown both isomers below. In the next slide, in next 2 slides, the examples of linear calibration curves of some representative pesticides are shown. The matrix match calibration was prepared for each matrix from 7 different calibration points in the range from 0 to 100 ppb or from 0 to 200 ppb. The R-squared value for all calibration curves were below 0.985. Here you can see the calibration curves of formation and Pyraclostrobin in all 3 matrices. Here is the last example of chromatogram of two pesticides, Acephate and Thiabendazole, in strawberry matrix, showing the peaks at LOQ level and corresponding calibration curves. So now Ed will continue in the presentation.
Okay, thank you, Katerina, for that great validation data there. What I'll talk about next is looking at high-resolution accurate mass and how well that compares with the TSQ Endura data. So one of the concerns that laboratories may have in moving to high-resolution accurate mass is indeed the instrument sensitive enough to obtain levels down to the guidance levels that are required for monitoring. And it turns out if you look at this graph here at the LOQs, you can see that the TSQ Endura LOQs compare very nicely with the high-resolution accurate mass QuEFocus LOQs. And as you can see there, about 200 of the compounds are easily in the 1 ppb range, which is the majority of the compounds in the method. And the evaluation criteria is also very important. The percent difference in terms of the calculated concentration against the calibration curve needs to be 80 to 120%, with RSDs less than or equal to 15% for 7 replicates at each concentration. So it's a pretty strict type of guidance there for the LOQs, as well as having a mass accuracy of less than or equal to 5 ppm. So this really helps us realize that high-resolution accurate mass in full scan can give us excellent quantitation down to levels that are comparable to the triple quadrupole technology. Also, calibration is very good with high-resolution accurate mass in the full scan mode, and you can see here 2 pesticides where we look at the accuracy and precision of 7 replicates at 1 part per billion, with accuracy easily 85 to 90%, with RSDs 5 to 6%, and coefficient of variations between 6 and 9%, with excellent linearity. And so there's plenty of scans across the peak for quantitation with the Orbitrap technology, and plenty of sensitivity as well. And this is very important for food labs that are looking into high-resolution accurate mass to be able to get good confirmation and quantitation at low concentrations in the matrices that they are studying. And of course, in this particular example, we show strawberry matrix here as an example. And so looking at the idea of high-resolution accurate mass in the analysis of QuECHERS type samples, you can see that the high-resolution accurate mass solution has been used by several universities to compare how well the compounds and pesticides are detected by high-resolution accurate mass in a complex QuECHERS extract, and then going on to doing data processing to find these compounds. And so the University of Almeria in Spain has done a lot of work in comparing Orbitrap technology with triple quadrupole technology and looking at detectability of the pesticides based on various settings in the mass spectrometer. So in the next slide, we kind of take a look at that. We look at the importance of mass resolving power for detecting pesticides in complex matrices. And as you can see here on the graph in the upper left-hand corner, we look at concentrations of pesticides in a tomato matrix between 10 and 500 ppb. And we look at the bars, and they represent resolutions of 17,500, 35,000, and 70,000. And it turns out that the Orbitrap technology enables easily resolution of 70,000, which is the routine operating resolution in the QuEFocus instrument. And as you can see, the number of pesticides detected increases with increasing resolution, and the linearity generally improves also. And also, the university found that the relative standard deviation at 10 and 100 ppb also improves when the resolution is better. So there is a very good relationship between mass resolving power of the instrument and the number of pesticides that you will detect with confidence in the instrument. And this is shown to even a further extent when you look at a more complex matrix like T. And as you can see here at 10 parts per billion, the resolution of 70,000 gets close to 95% of the pesticides detected. And that's a very important point, because at lower concentrations, you want to have confidence that you're able to detect the compounds at the required resolution so that you will not miss anything in the analysis. And so that resolving power becomes a very important factor when you consider high-resolution accurate mass in your laboratory. And so the other thing to look at with high-resolution accurate mass is how well the mass accuracy is maintained across a chromatographic peak. As you can see here, a compound in strawberry matrix at 5 micrograms per kilogram maintains excellent mass accuracy at approximately 2.2 ppm across the entire range of that peak. And the data-dependent MS2 analysis, which is the product line spectra obtained from this peak, also maintains excellent mass accuracy in its particular mass spectrum. And so that gives the user very excellent confidence that you're going to get good quantitation as well as confidence in identifying the compound in a complex matrix. And so here I talk a little bit about the variable data independent acquisition analysis. And basically this is a simplified methodology for both quantitative analysis and screening. So the quantitative analysis is done primarily from the full scan data obtained, and of course the screening data allows you to look for other compounds in full scan. You can look for compounds either during the analysis or retrospectively, and then you can also confirm them with MS-MS. And so what's great about this particular mode is that no target list is required, and you're running full scan all the time in the analysis at 70,000 resolution, and your MS2 spectra are being obtained at 17,500 resolution. And what you essentially do is you break up the mass range into specific segments, and then you do MS-MS on those specific segments, and then the data system will bring the MS-MS data and the full scan data together to help give you both a quantitative analysis with the full scan data and also confirmation with the MS-MS data. And so it's a very powerful technique that you can use to look for compounds that go beyond your target compound list. And a lot of laboratories today are required to do this because in the importance of food safety, we need to know what else might be in that sample that may be lurking out there that's not in our target compound list that would never be detected with triple quadrupole technology. And so here's an example of confirmation with this VDIA scan mode. And as you can see, it kind of looks like a triple quadrupole. You can have a quantitation peak and then several peaks you can choose for qualitative ions and doing ion ratio experiments just like you would in a triple quad. And as you can see here, this is the confirmation of azoxystrobin down at 1 part per billion. You're getting plenty of signal at 1 ppb. You're getting an excellent calibration curve, and you can do fragment pattern matching in the software as it's available for the analysis. And so this scan mode, is available pretty much globally except for in the US, and it's a very powerful scan mode that's available in the instrument. And so for high-resolution accurate mass, we think about confirmation techniques that we can use every day in the laboratory to help us give us confidence in our data. And so obviously the first kind of experiment that you'll do is you'll do a mass extraction window. So you want excellent mass accuracy, say less than 5 part per million, and you want to obtain that on a routine basis. And with the Orbitrap technologies, the mass resolution and sensitivity is basically maintained very well because you don't need to do a lock mass calibration. It's very stable, and it's stable for a very long time. So that mass extraction window becomes a very important confirmation technique in eliminating your background matrix. Then, of course, you can look at isotope pattern matching and use that as a way to help you identify the compound. The third way is look at fragment search if you have MS-MS data from full scan, data-dependent MS2 or VDIA scan modes. You can look at fragment searching results to give you identification. And then finally, a very important aspect that I want to talk a little bit more about is high-resolution accurate mass library searches that you can do from the data. And that's what's really nice is that you will actually have a full scan product line spectrum which you can use to do a library search and get more confidence in your result. And so what we've done is we've built some high-resolution accurate mass MS-MS spectral libraries and compound databases. And as you can see here in this particular database for environmental food safety, we have over 1,600 compounds that are basically individual compound spectra. And basically, these are great for confirmation of results. So what's kind of nice here is that you can have a target compound list in your high-resolution accurate mass, and then you can go off and search this database for other compounds that may not be on your target list. And so it's a very effective way of screening the sample for a lot of compounds very rapidly. And what we're doing here is we're increasing the number of spectra all the time in what we call a Thermo Fisher mzCloud approach, which I'll talk a little bit about in a later slide, which is a way to help improve and increase the number of spectra that are available for library searches. And so when you think about a high-resolution accurate mass library, there are really three things here that give you a really nice advantage. First is high confidence in compound identification, because you want to minimize false positives and false negatives, as well as eliminate matrix interferences. Secondly, it's an off-the-shelf database, so therefore it reduces method development time and saves you cost as a laboratory. And then finally, the library feature is customizable, so that new compounds and spectra may be added to the library at any time. And so you may want to set up your own library with your own scanning conditions going forward. And so these libraries are easily loaded into TraceFinder software. And what's nice is you can load in the high-resolution accurate mass library that I proposed earlier, as well as other libraries that are available that you can bring into the library search locally on your computer, and then run those libraries and use them against your data. And the other thing I wanted to mention was that not only do we have the high-resolution accurate mass spectral library, but we also have a compound database. And the compound database corresponds to the library. So in the MS spectral library, as I mentioned before, we have 1,600 compounds, but these 1,600 compounds contain spectra from 5 to 6 different energies. So at the end of the day, the MS spectral library contains about 7,000 to 8,000 spectra. However, the fragments and all the other metadata that go on with those compounds are present in these high-resolution accurate mass compound databases. And these databases are very important, again, to help you identify compounds. And what we've done here is we've based this compound database on retention times in the extended 25-minute method. So if a laboratory wants to set up a very quick screening method, they would set up the mobile phase and conditions for the pesticides that we use in the extended method, and then this database would correspond to the retention times in that method. And that way you would have accurate mass as well as fragments and retention time to help you identify the compound of interest. And again, it doesn't have to be on your compound list, and that's what makes this method very, very powerful for going beyond and looking at other compounds in a sample. And so here's an example of a library search result for boscalid. It shows that mass accuracy and sensitivity are not compromised on Orbitrap technology, and that's very, very important. So at low concentrations, you still obtain a high-quality mass spectrum, to which then you can get a library search result with a high score. And so that's really important. And as I mentioned earlier, that high-resolution ability of the instrument is very important in high-resolution accurate mass technology instruments. mzCloud, as I mentioned before, it's basically a cloud-based, web-based server, and it's a collaboration between not only Thermo Fisher Scientific but other collaborators that donate spectra, and it's a very, very comprehensive type of database. And so if you go to mzCloud, there's a lot of different metadata there. There's a lot of different spectral trees, going to MS to the N in a lot of cases. And the idea is to use mzCloud as a future repository for spectra, and then in future versions of TraceFinder, give one the ability to download these spectra to local databases to increase their particular database size. And so this will be Thermo Fisher's way of increasing library sizes, making more compounds available to the users, and really giving you the utmost in a comprehensive library going forward. And so if you're interested, go ahead and visit this site, take a look at it. It has a lot of information in it. It'll probably overwhelm you, but it's really quite a nice collection of spectra. And so just in review, I'll look at the Pesticide Explorer collection in terms of the software package that comes with the collection. So as we mentioned early in the slide presentation here, we have a quantitation package that's available for both the high-resolution accurate mass and the triple quad platforms, and it includes in software the TraceFinder version 3.2, along with the high-resolution accurate mass MS Spectra library if you decide to have the QuEFocus instrument, along with a USB stick that contains all the method and user guides to make it very easy for the lab to set up the analysis. And so it's a start-to-finish workflow. Everything is there and ready to go. And also, we have the screening and quantitation package, and that goes beyond just the standard MRM types of analysis or even Quan with a high-resolution accurate mass. And so that has other software tools to help you look at other compounds that might be in your sample in a retrospective way, such as Compound Discoverer and Mass Frontier, as well as Sieve, which helps you do PCA analysis for looking at comparisons between different sample types and trying to understand differences in samples. So a very powerful suite of software to really let you dig in and analyze high-resolution accurate mass data. And again, these methods are available on the USB stick, and the user guide really helps, especially new users, set up high-resolution accurate mass in a very rapid way. And that's really important because a lot of laboratories are new to high-resolution accurate mass and will definitely need some help to get used to the technology. And so I'd like to thank the contributors to this particular Pesticide Explorer collection. A lot of work went into this from a lot of our colleagues, and I want to thank them for giving us a really good package here. It's a really dynamic package, very easy to set up, and very easy for laboratories to get going. And with that, I want to thank you for your attention during this webinar. And if there are any questions, you can simply contact us here. I list a bunch of emails. You can email any one of us, and we'll be glad to get back to you with more information about the collection and about how you can get it for your laboratory. And with that, I want to thank you very much. And Thermo Fisher Scientific obviously has a global reach, and we're pretty much everywhere in the world that you can think of. Thank you for your attention.
Thank you for that informative presentation. Before we start with our question and answer session, I want to remind our audience how to submit their questions. You can submit your questions by typing them in the Q&A box, which can be found by clicking on the green Q&A button at the lower left of the presentation window. We'll try to answer as many of your questions as we can. Please note that Ed George will not be available during this Q&A session, but Katerina has agreed to field all of your questions. And our first question from our audience member is in our queue now. How does the peak shape of the early eluting pesticides look like, for example, the Acephate or chlormequat? Katerina, could you answer that question?
Good morning, good afternoon. Here is Katerina. Yes, I'm happy to answer this question. Yes, actually, thanks to very low injection volume, only 1 microliter, we have very good peak shape even for these very early eluters. We made some tests, and with high injection volumes, like 3 microliter, the peaks were tailing and the peak shape was unacceptable. But with 1 microliter, everything is fine.
Great, thank you. We do have another question. Were the values of LOQ under the MRL levels for the compounds which have MRL higher than 10 ppb?
Yes, our LOQ values for all 3 matrices for which we validated our method and we tested our method, LOQs were under levels of stipulated MRL values.
Great, thank you. We do have another question. Could you tell me which instrument is more sensitive, the triple quadrupole or the HRAM?
Okay, in this presentation we were talking about 2, actually more methods for 2 triple quadrupoles, TSQ Endura and TSQ Quantiva, which is high-end instrument, and high-resolution accurate mass spectrometer QExactive Focus and QExactive. So if shall I compare TSQ Endura, triple quadrupole, and QExactive Focus or QExactive, here the sensitivity is comparable. TSQ Quantiva is a little bit more sensitive. We can say roughly 10 times more sensitive than TSQ Endura. I hope that I've answered the question correctly.
Great. Thank you for that. We do have another question. What would you personally recommend as a method for HRAM instrument? VDIA or VD full scan? Which one do you prefer?
Okay, here I personally prefer the usage of VDIA because you don't need to know the precursors and set it for the confirmations. However, at this moment, this method can be used in the US, but in Europe, there are no restrictions. So I'm definitely for VDIA.
Great. Thank you for that answer. I just want to see if our audience has any more questions. Wanted to let them know we do have Katerina here to answer any questions that you have about today's presentation. And we'll just give that another minute to see if we have any of our attendees who would have questions. And I don't see any in the incoming Q&A. I'd like to just turn it back to Katerina now for any final comments or thoughts that she has for the audience on today's presentation.
Actually, I think we are becoming one more question. Am I right?
Oh, let me see if we have that. And I don't see any, oh, here we are. What categories of substances interfere with accurate analyses with this equipment and methods?
Okay, I think it can be more type of substances, for instance, some pigments in Leek especially, or some acids, because we are using for sample preparation QuECHERS, and this method is very fast, easy to use, but and as we don't use cleanup, the final extract is not so clean, so there can be really some interferences. But thanks to using triple quadrupole or high resolution mass spectrometer for determination, they should not interfere. There should not be big problems with interferences.
Great. Thank you for that. We do have just a comment from our audience, which I always think is nice, saying the presentation is excellent. Thank you for that. And we would still like to take any more of your questions if you have them for us. Katerina is here to answer those. And I don't see any in the tag. Katerina, maybe you want to
yes, maybe I would like to just thank you, the audience, for listening to our webinar, and I hope that it will be helpful for you for your routine work in the labs. And if you have any questions, please contact us. We will be very happy to help you. Thank you.
Thank you, Katerina, for spending time with us today and bringing us this presentation. I would also like to thank our sponsor, Thermo Fisher Scientific, for making today's webcast possible. Today's webcast will be available for on-demand viewing through May of 2016, and you'll receive an email from LabRoots alerting you when this webcast will be available for replay. We invite you to forward that announcement to your colleagues who may have missed today's live event. That's all we have for today. Thank you for joining us.